Hello, my name is Alyssa Jones, and my presentation is over spatial and temporal prevalence of Aedes albopictus in Arkansas. And I'm from Arkansas Tech, and I worked on this project with Dr. Eric Lovely and Dr. Douglas Barron. So I focused on Aedes albopictus, which is a vector species for many arboreal diseases. These include dengue, chikungunya, yellow fever, along with Zika. These diseases can cause significant increases in morbidity and mortality rates worldwide. And I've shown a picture of Aedes albopictus down below. As you can see, it has the white stripes. Our project arose because there is a deep need to broaden the knowledge on Aedes albopictus. This is because very little is known about its spatial dispersion, and environmental factors such as its location, of its origin, as well as the origin of where it picked up the disease, have a huge impact on the species' competency as a vector. Our project should be able to increase tracking, which would allow a better understanding of the factors associated with its range in Arkansas. So our study, as I stated before, was to track the distribution of Aedes albopictus and find patterns to better understand the species and how it moves. And like I said, we studied this through space and time, so we looked at each county as an area of space and then looked at it through multiple months over the course of 2 years so that we could get a good idea and set a pattern over multiple months and including multiple years. As I stated, our data was obtained over 2 years with many counties in Arkansas submitting data, and it focused on Aedes albopictus specifically because research indicates it's much more prevalent than its counterspecies, Aedes aegypti, in Arkansas. If you look to the right, you'll see two maps from a paper I found from Monaghan et al. That was written in 2019. And up above, you'll see the Aedes aegypti map, which indicates that it's far less prevalent than the Aedes albopictus, which is pictured in red in the bottom map. And this is important because Aedes aegypti is more frequently known as the better carrier for these arboviruses, but Aedes albopictus is what is most common in Arkansas between the two species. So our methods were, we had oviposition traps that were established throughout the state, throughout multiple counties, and these were set up to target container breeding mosquitoes, such as those in the Aedes genus. These were made from 16-ounce cups, which were half full of water, and about half of a palm full of grass or hay, along with some rocks, was placed into this water for about a week so that the nutrients could soak in and the hay and grass could decompose to where it would be favorable for the mosquitoes to breed in that area. And so once all of the hay and grass had set in for about a week, then the traps were able to be set out and observed by our Arkansas Health Department helpers. So the average time span that our traps were set out was about 7 days. It varied though, but from 2 to 21 days. And to correct for that big variance, we divided the number of eggs in each trap by the number of days it was left out. That way we didn't have any huge errors coming from one trap being left out for 1 or 2 nights and only having a handful of eggs at most, versus another trap that was left out for nearly a month and had hundreds of eggs. So that way we were able to correct for that. And if you look to the right hand of the screen again, you will see a photo detailing the eggs on the trap paper. These traps were then dried by the Arkansas Department of Health staff members that were helping, and they were mailed to Arkansas Tech University, where students were able to count them using a dissecting microscope. We did allow eggs to germinate, and 99.7% that germinated were identified as Aedes albopictus. But because only 7% of the eggs that we tried to germinate did successfully germinate, we focused on egg abundance versus germination rates. As far as our statistical methods go, when looking at county data, we gave each individual county its own latitudinal point and grouped all of the data from that county together. And this was done using location data on Google. So we would search the latitude for that given county and then assign it to that county alone, and then go on and do that for each county that submitted data. Counties were also grouped into north, middle, and south categories, and this was done by taking the 10 northernmost counties that submitted data and labeling them north. The 10 southernmost counties that gave us data were labeled south, and the 10 most central counties that submitted data were labeled as middle. So then our count data was square root y plus 0.5 transformed to try to make it more normal. This gave us qualitatively similar results as the raw data did, and so we use raw data in figures to simplify the interpretation. The number of eggs in a trap per night was compared to the latitudinal value, the month of the trap collection, as well as the county trap collection. All of the comparisons were performed using linear regression on ANOVA and ANCOVA on the program NCSS. So here are our results, and whenever we compared the number of eggs per night to the month that they were collected, you can see that 2016 and 2017 both had peaks in July and August on egg abundance, whereas in 2016 it wasn't quite significant. It had a p-value of 0.08, whereas in 2017 it was highly significant with a p-value of less than 0.001. In 2016, higher latitudes had lower egg counts, and that is on the left. And in 2017, higher latitudes had higher egg counts. Now, in 2016, this data was highly significant with a p-value of less than 0.001. And in 2017, it was significant and had a p-value of 0.03. Now, this data could have done this for multiple reasons, but we will get into that later. The following figure includes the latitudinal categories compared to the number of eggs per night. And as you can see, it follows the same trend as the previous slide did, where 2016 had higher trends in egg abundance in the southern and middle counties throughout the year, whereas in 2017, the northern counties clearly held the most egg abundance. Now, when looking at these two figures, this is when both month and latitudinal category were considered across the eggs per month. And for this, in 2016, the figure on top, you can see that when month and category were considered, month was significant with a p-value of 0.03, and latitude was highly significant with a p-value of less than 0.001. You can also see that the southern and middle values had your higher egg abundance of that year, which ties into the other charts from this presentation. Whereas in 2017, you can see that month was highly significant with a p-value of less than 0.001, but latitude was not significant with a p-value of 0.28. You can also tell, though, that in 2017, the northern counties did have the highest egg abundance, which once again ties into the other charts we've seen so far. Okay, so on this slide, you can see our map that we made based on the 2016 data, and this ranged from June to November of 2016. And you can see that between the counties, there was significant variance with a p-value of 0.001. You can also see that the southern portion of the state is where the most egg abundance was, but you can also tell that the southern counties were the ones that submitted more data, whereas we had very few counties that participated in the northern part of the state for 2016. Now, this could create a bias and some errors in drawing conclusions, and it's important to note that. Okay, and on this slide, we have the video that depicts month-by-month variation through the counties of Arkansas. I'm going to go ahead and press play on that while I give you an intro on it. So, as you could have seen, in June we had lower egg abundance that started out in the southern areas. Through July and August, egg abundance increases and spreads more northward. And by September, egg abundance throughout the whole state is starting to dwindle again, especially noticeable in October. All right, thank you. We'll go to the next slide now. This slide shows the 2017 county-based data for all of 2017, which spanned from April until October. And once again, you can see that there is significant variation among the counties throughout the year. And you can also see that once again, we had very many counties that did not submit data, and those are indicated by the gray counties that you see on the map. Okay. And then in this slide, we have the video for 2017 month by month. And so that's playing for you right now. And once again, you will see that it started out with lower abundance, and then it slowly started to move more northward. Now, it seemed to move more northward quicker because in June, you could see that those counties in the north area started having abundance, whereas in the 2016 video, it took until September or so. Okay, and then I'm going to go ahead and click on that one more time and let that play through. Like I said, in April, very few counties. In May, very low abundance throughout most of the counties that submitted. June, you're seeing the counties in the north start getting darker coloration. And in July, once again, higher abundance through that darker coloration. And then it just plays on and starts to dwindle after August. Okay. So based on our data and the counties that participated, it appears as though Aedes albopictus prevalence spreads northward from spring to August, and the prevalence decreased over the state as the fall months arrived. This could be linked to weather patterns in these areas, as well as it could be due to the bias of the lack of counties that participated in the study. The maps on this slide and the one following it will let you visualize the July and August peaks in egg abundance, which was seen in both years despite having different weather patterns throughout the years. So in 2016, you can see in July there were more southern egg abundance, whereas in 2017, the higher abundance was in the north. And then in August of 2016 and 2017, you can once again see that in 2016 there was more abundance in the north, or in the south, I'm sorry, and in 2017 it was more balanced out by August. Now, once again, you can also see that we are lacking quite a few counties, so this data could be very much improved with the addition of more counties participating in a future study. So the weather between the years is important to acknowledge because 2016 was acknowledged as the hottest year in U.S. history, but was closely followed by 2017. 2017, though, had higher precipitation, including increased flooding and hurricane occurrence. This was interesting because both years still had the same peak abundance timeframe, and 2016 showed data favoring southern latitudes, and 2017 favored northern latitudes. Upon further research, we did find that egg abundance should increase with temperature as well as precipitation, so it'd be interesting to see which one of these plays the higher role consistently over patterns in the species across the country. That way we could tell if it was the weather in this case that caused the differentiating peak latitudes, or if it had to do with the data available due to the counties that participated. So as far as our data and future studies, we would like to expand to include all the counties in Arkansas to increase our sample size. We also think that our data could be used to map Aedes aegypti prevalence if or when they become known to inhabit Arkansas more consistently. We also think it could be used to understand vector competency in Arkansas, as vector species across varying regions could have different competency if we ever want to use this data for that purpose. We also think it's important to increase the knowledge of the geographical range of Aedes albopictus since it is such an important vector species. And it is also possible to use these methods across larger geographic areas such as the whole country. I would also like to thank a group of people that helped us with this study, which include the Arkansas Department of Health staff, the Arkansas Department of Health for giving us the grant to do this study, and the students at Arkansas Tech University that helped us with this, which include Grace Rice, Colton Barrett, and Rachel Kottner. And that is my presentation. Thank you all so much for your time, and I hope you enjoyed it.